Hello everyone, welcome back to VSR Physics Academy. Myself Swapna Varala, I am going to teach you CBSE 9th and 10th physics classes. In this video, we are going to learn about complete refraction of light. What is refraction? What is the cause of refraction? What are the laws of refraction? What is optically rarer medium, denser medium? What is refractive index, relative refractive index, absolute refractive index? What is the difference between them? Few numericals, also rectangular glass slab. In our previous video, we have discussed about 5 amazing tips how to solve the numericals. Complete reflection regarding reflection. If you don't watch the video, kindly watch the video. This is a part 4 video. Let's start the video. So, my dear students, coming to the refraction. So, what is refraction? Many times, whenever we have observed, that means when we stand in front of the pool, if we observe, the water will be less. Until and unless whenever we are jumping into the water will be more. Why this is happening? Also, whenever we are taking the glass of water and putting a pencil in that, the pencil appears to be bent. Why this is happening? Also, even whenever we are going to the shops and taking, if you observe, they used to put the lemon in the glass of water, and if you observe the lemon compared to the actual size, it appears bigger. Even when you are putting the stick into the water, it appears to be bent. This is all because of the refraction of light. This is all because of the refraction of light. So what is refraction? So reflection we know. Reflection means bouncing back of light into the same medium is called as reflection. But what is refraction? Refraction is nothing but bending of light. Bending of light when ray of light, when light enters, from one medium to another medium. Bending of light when light enters from one medium to another medium is called as refraction. So simply, I can explain the refraction in simple terms. Like speed of light. What is the speed of light in water? Speed of light in water is 3 into 10 to the power of 8 meter per second. Sorry, speed of light in air is 3 into 10 to the power of 8 meter per second. Speed of light in glass is 2 into 10 to the power of 8 meter per second. Whereas speed of light in water is 2.25 into 10 to the power of 8 meter per second. So here the speed of light in air and glass both are same? No. The speed of light in air is 3 into 10 to the power of 8 meter per second. Speed of light in glass is 2 into the 10 to the power of 8 meter per second. Speed of light in water is 2.25 into 10 to the power of 8 meter per second. The speed of light will be different in different medium. So that's the reason. This is the keyword. The speed of light will be different in different mediums. So that's the reason. The ray of light, when it is moving from one medium to another medium, it will bends. The direction or path will changes. So this is called refraction. Okay, so this is called refraction. Why it is changing? As it is moving from one medium to another medium. The speed of light will be different for different mediums. So that's the reason the ray of light, the light ray will bends. The light ray will bends. There is a change in its direction or path. This is called as refraction. So what is the cause of refraction? Refraction we know. What is the cause of refraction? Speed of light will be different in different medium. So that is called as refraction. In refraction, we'll discuss about, before knowing about the three cases, like when a ray of light is moving from optically rarer medium to denser medium, and when a ray of light is moving from denser to rarer medium. When a ray of light is incident normally, we should know about what is optically rarer medium and optically denser medium. So, optically rarer medium. What is optically rarer medium? If the medium in the medium, the speed of light will be more or increases, then that medium is called as optically rarer medium. So the speed of light will be more or increases. Such medium is called as optically rarer medium. Example, air. Okay. Next we will discuss about optically denser medium. So in this medium, optically denser medium, in this medium, the speed of light will be less or decreases. The speed of light will be less or decreases. So example, water, or you even take glass. So optically rarer medium means the speed of light will be more or increases. Optically denser medium means the speed of light will be less or decreases. Example, water or glass. In water or glass, the particles will be closely packed. That means dense. So the particles will be dense. So that's the reason the speed of light will be less. Whereas coming to the optically rarer medium, the speed of light will be more. So the particles are going to move randomly. So it will move in different directions. So the speed of light will be more. Whereas in optically denser medium, the speed of light will be less. Example, water and glass. This is about optically rarer medium and optically denser medium. So this is about the refraction, bending of light when light enters from one medium to another medium. As the speed of light will be different for different mediums. So there is a change in path. There is a change in path. There is a change in direction. So the light ray will bend. Okay, so this is called as a refraction. So why? What is the cause of refraction? Because there is a speed. The speed of light will be different for different mediums. So that's the reason the change in direction. The direction of light will bends. Okay, so this is called as refraction. And the speed of light in air is 3 into 10 to the power of 8 meter per second. Glass is 2 into 10 to the power of 8 meter per second. And water is 2.25 into 10 to the power of 8 meter per second. Okay. So if you want to note it, please note it. Next, we'll discuss about three cases. In that case number 1, when ray of light is when ray of light moves from rarer to denser medium. When ray of light moves from rarer to denser medium, what happens? Let us see. So for this, we need to draw one horizontal line and one vertical line. This is called as normal. Always normal should be drawn with the dotted lines only. And why it is called normal means a perpendicular line drawn to the surface is called as normal. So when a ray of light is moving from rarer medium to denser medium, always the ray of the incident ray will be obliquely, it will incident. Obliquely it will be incident. And if you observe, when a ray of light is moving from rarer, you can take like air to air is rarer, take glass or water. So denser, what happens when it is moving from rarer to denser medium? Actually, the path of light will be reflected into the same medium. So what happens when a ray of light is moving from rarer to denser? So like most of the people will teach like complete ray of light will be refracting. No. When a ray of light is moving from rarer to denser, a part of light, that means like 10% of light will be reflected into the same medium. Remaining 90% of the light will be reflected, as it should move like this, but instead of it is bending towards the normal. This is the incident ray, this is refracted ray, this is reflected ray, this is incident ray. Incident ray, reflected ray, and this is what? Refracted ray. Okay, so when a ray of light is moving from rarer to denser, actually it should move like this. Why it is bending towards the normal? It bends towards the normal. Why? Because rarer to denser, it bends towards the normal as it is moving from one medium to another medium, not same mediums. So that's the reason it is bending towards the normal. And here the important things are when a ray of light is moving from rarer to denser, its speed of light rarer to denser d decreases. How should remember means rarer to denser d decreases. Its wavelength also decreases. But frequency does not change. There is no change in frequency. Does not change. Okay, when a ray of light is moving from rarer to denser, its speed of light decreases, wavelength increases, and frequency does not change. There is no change in frequency. It depends on the source of light. Okay, so speed of light decreases, wavelength decreases, and frequency does not change. And it bends towards the normal. So this is about when a ray of light moves from rarer to denser medium. So let us see the second case. So case number 2. Here denser to rarer. So here you take glass, denser, air, rare. So whenever a ray of light moves from denser to rarer, a part of the light will be reflected into the same medium. Remaining part will be refracted. So as it is moving from denser to rarer, actually it should go like this, but there is a change in medium. As it is moving from one medium to another medium, it should bend away from the normal. It bends away from the normal. Okay, so actually it should move like this, but what it happens, it bends away from the normal. Like this it will. Okay, it bends away from the normal. So this is what refracted ray. This is angle of incidence, this is angle of refraction. When a ray of light is moving from denser to rarer, it should move like this instead of that, as it is moving from, as it move like this, but it is bending away from the normal. Why it happens means the speed of light increases. So when a ray of light is moving from denser to rarer, speed of light will be increases. If speed of light increases, wavelength also increases. But there is no change in frequency. Frequency does not change. Frequency does not change. There is no change in frequency as it depends on the source of light. Okay, so again, when a ray of light is moving from denser to rarer, it bends away from the normal. A part of the light will be reflected, remaining part will be refracted. This is angle of incidence, this is angle of refraction, incident ray, and this is the refracted ray. Speed of light will be increases. If speed of light increases, wavelength also increases, frequency does not change. So this is about case number 2. Last but not least, one more case is there that is very, very important. When a ray of light incident to normal. So if it is incident normally, what happens? Let us see. If a ray of light incident to normally, what happens? Again, we need to take we need to draw one horizontal axis, and as it is incident normally, here 90 degrees we will get. It passes undeviated, whereas angle of incident will be 0, angle of refraction also 0. So why it passes undeviated? Why it passes undeviated means irrespective of, as it is moving from rarer to denser or denser to rarer, it passes undeviated. Why? Because it is incidenting normally. Normal means 90 degrees. And its angle of incident will be 0, angle of refraction will be 0. This is very, very important. You can give 5-star rating. Very, very important. When a ray of light is incident normally, its value will be 90 degrees. It passes undeviated. Either it is moving from rarer to denser or denser to rarer. Its angle of incident will be 0, angle of refraction also 0. And here it passes undeviated. These are the arrow marks. Okay, you need to place these arrow marks properly. If you are placing, if you are not placing properly, this will be wrong. Understood? Is it clear? Next, we will discuss about laws of reflection. Laws of refraction. Laws of refraction. In that first one is the incident ray, refracted ray, normal at the point of incidence, all lie in the same plane. Here, what is the keyword? Normal at the point of incidence is the keyword. Okay, whenever you are writing the laws of refraction, the incident ray, refracted ray, normal at the point of incidence, all lie in the same plane. That is the keyword. If you are not writing that, you will not get the mark. Okay, the incident ray, refracted ray, normal at the point of incident, all lie in the same plane. So this is the first law. And the second law is given by a Dutch scientist, Wilbrod Snell. Wilbrod Snell. So based on his name, Snell's law we got. If I invented this law, my name will get. Okay, sorry, I'm just kidding. So Wilbrod Snell, based on the Dutch scientist name. So Snell's law. What is Snell's law? The ratio of sine of the angle of incidence to sine of the angle of refraction is equals to constant, which is represented with mu. Okay, so the ratio of sine of the angle of incidence to sine of the angle of refraction is equals to constant, where constant is represented with mu to 1, not meow, mu. How to write this mu? Again, students will make mistakes. So we need to draw one vertical line, another 1/4 vertical line. Between you need to put u, here one curve, here one curve. So this is nothing but mu. So mu is nothing but refractive index. So what is refractive index? This is very, very important. Refractive index is very, very important. Very, very important. Why? Because we'll get the numericals based on the refractive index in the CBSE board exam. So refractive index, what is refractive index means? Refractive index is defined as the refractive index of second medium with respect to first medium is defined as the ratio of sine of the angle of incident to sine of the angle of refraction is called as refractive index, which is represented with mu. Again, I'll repeat. Refractive index of second medium with respect to first medium is defined as the sine of the angle of incident to sine of the angle of refraction is known as refractive index. Okay, this refractive index is again classified into two types. That is very, very important. Most of the students will face the problem there only, and they'll do the mistakes in refractive index. They'll get confused about the refractive index. I'll clarify about this. So kindly note down the refractive index terms. Okay. This refractive index is classified into two types: relative refractive index and absolute refractive index. Relative refractive index. Absolute refractive index. So this relative refractive index is given as mu is equals to C by V. That means refractive index is equals to, in numerator we'll get speed of light in air or vacuum, speed of light in air. In denominator you can take any medium. So speed of light in that particular medium, any medium means you can take glass, air, like that. Okay. And this is nothing but relative refractive index, whereas absolute refractive index is, if you are taking like mu 2 1, most of the students will make mistake here only, how to write it. When it comes to the speed of light, here in numerator, first you need to write the medium 1. So speed of light in medium 1 to speed of light in medium 2. For example, if I'm taking here air, here I'm taking like glass, and here I'm taking water. So what should I write here? First I should write water, speed of light in water value and speed of light in glass value. Okay. Or if I'm taking like water and glass, water and glass. So what I should write here? First I'll write medium 1. After that I'll write medium 2. In this way we need to write when it comes to the speed of light values. But whenever you are writing the refractive index terms, first you'll write the second medium and next you'll write the refractive index of medium 1. So how to say this one means, refractive index of glass with respect to water, refractive index of water with respect to glass, refractive index of medium 2 with respect to medium 1. Okay, in that way we need to say, and it is also represented with N21, N12, like that. Okay, in CBSE terms it is also represented with N21, N12. Okay, or it can also be represented with the mu. Okay. Next, I'll explain few numericals so that you'll get more clarity about this refractive index and absolute refractive index. So coming to the relative refractive index, question is, speed of light in air is 3 into 10 to the power of 8 meter per second. Glass is 2 into 10 to the power of 8 meter per second. Calculate its refractive index. Calculate its refractive index. So given mu is equals to, solution, mu is equals to, C is 3 into 10 to the power of 8. As I said, in denominator you can take any medium. Okay, so 3 into 10 to the power of 8 and 2 into 10 to the power of 8. Any friends are there? Yes, both will be cancelled. So 3 by 2. So this you can leave like this, or this you can be converted in decimals also. 2 ones are 2. So 0.10, 2 fives are 10. So refractive index of what glass is 1.5. For refractive index there will be no specific units. Why? Because it is going to be dealing with different mediums. So there is no particular units for refractive index. So this will be 1.5 only. Next, coming to the relative absolute refractive index, question will be given like this. Question will be given like this. What is the question means? Speed of light glass with respect to water. We'll solve glass with respect to water. So how to do this means, you can first how to write means refractive index of glass with respect to water. Okay, so here medium 2, here medium 1. So while you are writing, what you should write? Water value. Water value is 2.25 into 10 to the power of 8. Glass is 2 into 10 to the power of 8. Okay. Now friends are there cancelled. So this can be written as, after point 2 digits are there. 225 by 2 into 100. So 225 by 200. 540s, 545s, 5 nines, 5 eights. So 8 divided by 9. Okay, 8 ones are 8, 1, 0. 8 ones are 8, 2. 8 twos are 16. 8 fives, 40. So what is the value here? How much I got? 1.125 is the refractive index of water. Okay, sorry, 1.125 is the speed of light with respect to glass with respect to water value is 1.125. So similarly, you can calculate the speed of light water with respect to glass. So how much we got, that also we can see. So here you just change water, here glass. So here water gets speed of light with respect to water. Water with respect to glass. So here I'll get, in numerator we'll get 2. Okay. So 2 into 10 to the power 8 and in denominator 2.25 into 10 to the power 8. Both will be cancelled. So 225 by 100. So 2 into 100 by 225. 200 by 225. 5 40s, 5 45s, 5 8s, 5 9s. So 9 divided by 8, how much you will get? 0. Okay. 9 9s 81, 9 8s are 72. So 8, again 0. 9 8s are 72. 8 0. So like that it will be. So value can be taken as 0.89. There is no specific unit. So in this way you can say whether it is absolute refractive index or relative refractive index. Even here you can take like speed of light in air is 3 into 10 to the power of 8 and here you can take speed of light in water. That also I'll calculate and I'll show you. So water value is sorry, this marker actually it is disturbing a lot. So water is 2.25 into 10 to the power 8 meter per second. So mu is equals to C by V, no? So 3 into 10 to the power 8, 2.25 into 10 to the power 8, both will be cancelled. So 3 by 225 by 100. So 3 into 100 by 225. So this can be given as 300 by 225. So 560s, 545s, 512s, 59s, 34s, 33s. If you calculate 3 divided by 4. So 3 ones are 3, 3 threes 9, 3 threes 9. So like that it will be continued. So the value is 1.33. So the refractive index of water is 1.33. Refractive index of glass is 1.5. So how to identify relative refractive index and absolute refractive index? Hope you understood. Next we will discuss about rectangular glass slab. Refraction of light through rectangular glass slab. This is very important topic. Also in the last year question paper, they have given the CBSE board question paper. In the board, they gave this question. So it's very important. I'll explain you in detail. In the textbook, NCERT textbook, they gave you, and even this is also an activity. This should be done in lab. So first what you need to take means you need to take one rectangular glass slab. Take one rectangular glass slab and you need to trace this rectangular glass slab. With the help of rectangular glass slab, you need to draw the outline. So next you can mention this as mention it as like PQRS or you can take even ABCD. So how to, you need to, what happens when a ray of light is moving from air to glass medium, that we are going to see now. So whenever you are taking this, take a rectangular glass slab and you just draw its outline and draw the normal first, draw the normal. Later you need to draw one incident ray. So here you need to draw one Incident ray with the help of protractor, either you can take like 30 degrees, 40 to 40, 50, 60 like that. So you need to take one, you need to draw one incident ray. After that, you need to put the 2 pins. So place again the rectangular glass slab. Here you need to place the 2 pins. After that, by observing from here, you need to, pins means you need to take the drawing pins. Drawing board pins will be there. On the boards you'll use to stick note. That one you need to take and you need to place one rectangular glass slab. By observing this from here, you need to mark somewhere you'll get, and you need to measure this angle of incidence will be there. No, this will be less than angle of refraction. Okay. Now, in terms of actual terms, if you are discussing when it is moving from rarer to denser, so what happens when it is moving from rarer to denser? It bends towards the normal. It bends towards the normal. This is angle of incidence. This is angle of refraction. This is refracted ray. This is incident ray. But actually, the incident ray should move like this, but it is bending. Why? Because it is changing the medium. As it is moving from rarer to denser, it bends towards the normal. Okay. Now, as it is touching again, we'll get the normal. And the ray of light is moving from denser to rarer, it bends away from the normal. It bends away from the normal. This is called as emergent ray. This is angle of incident, angle of refraction. Emergent ray. This is called as emergent ray. And this is normal N and this is N dash. And these two lines will be parallel. This is called as lateral displacement. This is called as lateral displacement. Very, very easy. Lateral displacement, and this is incident ray only. This is incident ray. Both will be parallel. Make sure if both lines, if you are getting parallel, then only your experiment is right. So this, maybe they can ask you to draw the diagram. Most probably they will not ask you to draw the diagram. They'll give you the diagram and they'll ask you to label the parts. So this is the incident ray, refracted ray, emergent ray. So how to do this also I have explained. So this is how you can remember this refraction of light through a rectangular glass lamp. If it is moving to rarer to denser, bends towards the normal. If it is moving to denser to rarer, it bends away from the normal. So my dear students, hope you understood this refraction, complete refraction terms I have explained. So if you are having any doubts regarding the topic, please post a comment in the comment section. If you like this video, please like this video, share to your friends so that you'll get the notifications about my video. Also, thanks for watching.